Apollo 15 arrived at the moon without a hitch. Even though its landing site was the trickiest yet. But what is this place they've landed on? This moon that is bigger and closer to its host planet than any other moon in our solar system. What can we learn by actually being there? About its age, its origins, its crater-torn surface. The Hadley Apennine landing site is located near Imbrium crater, so large it can be seen from the Earth. Scientists believe the crater was formed by a huge meteor impact when the moon was young. That catastrophic collision must have kicked up rock from deep inside the lunar crust. Geologists Jim Head and Lee Silver, glued to their television screens in Houston, hope Apollo 15 is in a good spot to find some of this ancient material called anorthosite.
Anorthosite, that would be the deep crust that we could look at and understand. And Dave went up to the side of the mountain and he looked over and he saw this sparkling crystals glinting at him, which is rare for the moon.
Boy, that's a big mountain when you're down here looking up, isn't it? Guess what we just found? Guess what we just found? I think we found what we came for. Crystal and rock, huh? Yes, sir. You better believe it. As a matter of fact, oh boy, I think we might have ourselves something close to anorthosite, because it's crystalline. And that is really a beauty, and there's another one down there. Yeah, we'll get some of these. Bag it up.
It turned out to be, we think, a sample of the original crust of the moon, made 4.5 billion years ago, right after the initial formation of the moon.
The anorthosite Dave Scott brought back is a jewel in the crown of lunar exploration, the oldest sample yet found. The press dubs it Genesis rock. Its surprising age and chemistry, along with evidence from the other lunar samples, gradually lead to a radical new theory of the moon's origin. 4.5 billion years ago, Earth was struck by a Mars-sized asteroid. This giant impact sent a massive amount of material into orbit, which coalesced, forming the moon. The theory, ridiculed at first but now widely accepted, was developed by planetary scientist William Hartmann.
Apollo itself tied together the history of the moon with the history of the Earth, so that it made us aware that we live in this system. We're not just living on an isolated planet, but we have this neighbor, and the neighbor records the early history of the system because there's virtually no erosion there, and the Earth records the last part of the history of the system. But if you put the two together, we get the whole story.
The moon's presence changed the Earth in profound ways. Its gravitational pull stabilized the young Earth's wildly fluctuating axis of rotation, setting up the conditions for everything we take for granted about our planet: moderate temperatures, liquid water, tides, life itself.